If you are watching this video, I'm going to assume that you were present in class on Wednesday, August the 31st, to collect your data with the Dune Buggies and the spark timers and the spark tape. If you were not present in class to collect this data, you should not be watching this video. So the first thing that we're going to do, hopefully you already have your journal pages set, page 8 and 9, with the title Dune Buggy Lab. And the first thing that we're going to do is to just glue the data chart down on page 8. And just a little dot of glue on each corner will hold it just fine. Glue it down just like that. The next thing that we're going to do is attach our graph paper onto page 9. And there's a very specific way that we're going to attach that so that we can graph on it but still use the journal page underneath. So the first thing we do is to just lay out our two pieces of graph paper. Leave a little space in between. Make sure they're not overlapping. You want them to be nicely spaced on the page. Then you're not going to lift them up again. From this left side, fold a little tab and then put just a little bit of glue on that tab. And then just fold it back open, just like that. So now I can graph on that, but I can also lift it up out of the way. And I moved this one, so we'll fix it. Again, not going to pick it up off the page. We're going to just fold to the edge, put a little glue on it. And if you're using tape, obviously you can do this with tape. If you have your own glue stick, you can do it with a glue stick, but here we go. The next thing that we need to do is gather our data in a way that makes sense. So because we're going to be graphing all 4 of these data charts here onto one graph, I need some way to distinguish which part of the graph goes with which data chart. So I'm going to just take 4 different colored pens and I'm going to mark my chart header. So this dark blue will be for the first one. This light blue I'll do for the second one. Just mark your data chart somehow. You can put a dot or you can circle the chart headers like I'm doing. You can shade it in. Whatever you want to do to indicate which color goes along with which data set. So there I've got 4 colors and 4 sets of data. Now I need to get my graph ready, and I'm just going to focus on this one on the top first. So the first thing I want to do is to draw in my X and Y axes. So to draw my X axis, I'm going to go the second line up from the bottom. And this is a little bit different maybe than how we usually would do it. And it's really just to make sure that everything will fit on your graph properly. So then we're going to start counting from the end and count our way backwards. And we know that our last time mark was 1.0 seconds, so I'm going to make that the end right here. I'm going to skip a line so that I can space out my graphing a little bit. And that's 0.9, skip one again, 0.8, skip, 0.7, skip, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1. And now you can see my 0 would be right up against the edge of my graph, and that's okay. So I'll go ahead and draw in my y-axis now. And before I do anything on my y-axis, I'm going to label my x. And you can see I don't really have any space left on the actual graph paper, so I'm going to just write it on the journal page right underneath. And it's okay if it goes off of your graph paper just a little bit, because you can still see where it belongs. So time in seconds, and then I've got my x labeled here. Now on this graph at the top, we're going to be plotting our time and our total distance. So our label for the y-axis is total distance in centimeters. But how do I do that? I have to scale my axis first. So the way to scale your axis is to look at all of your total distance column and figure out what is the highest number that you have out of all of your data sets. And for mine, it's this right here, 41.6 centimeters is my highest total distance. So I have to make sure that that will fit on my graph. So I'm going to take 41.6 divided by, and then I'm going to count how many lines I have available to work with on my y-axis. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to still include that one all the way at the top. So 41.6 divided by 13. And that gives me 3.2. Now I don't want to count by 3.2s. So I'm going to round that up to the next whole number and count by 4s. Why wouldn't I count by 3s? Because if I only went by 3s, I'm going to run out of space by the time I get to the top. So I'm going to go up to 4. And each one of these lines is going to be counting by 4. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 42, nope, not 42, 44, then 48, then 52 is what I was thinking of. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. Now my next step is going to just be to plot my data. So I'm going to start with my first set here. I'm going to ignore this middle column and only do time and total distance. So I've got my dark blue that I had marked that data chart with. So I'm just going to graph that, plot my points. Point 2 is at 4.8, point 3, 7.2, 0.4 is at 9.7, 0.5 is at 12 exactly, 0.6 is at 14.4. And remember, when you're graphing, you should be graphing your own data, not my numbers. Don't graph my information. Graph your own. If you don't have your own, you shouldn't be watching this video. If you don't have your own data, you should be watching the data collection video, which is different. So here's my first set of dots. Then I'm going to take my ruler and I'm going to draw a straight line that starts at the origin and ends right here at my last dot, which I know is at 24.2 centimeters. Now, why am I drawing my line this way? You think back to the tile lab. When we graphed everything for the tile lab, we drew a best fit line that was kind of the average of everything. And the reason for that is because we weren't really confident about our areas. We didn't know for sure really that that's what the area was. But this, we can feel pretty confident that after 1 second, this is exactly how far our dune buggy went. We started measuring here and we ended measuring here, so we can be pretty confident it's just one total. And so that's why we can say it started at 0 and it ended here. And if the dots are a little wavy on the way up, that's okay, because we know that's exactly how far it went after that much time. So now I'm just going to add my other 3 data sets. I'm going to do exactly the same thing. I'm going to plot all of my points, and then I'm going to draw my line. So it's really helpful if you plot your points and then draw the line immediately. If you try and plot all of your data points and then draw all of your lines, it can get really confusing as to, wait, which one am I supposed to be drawing with which color? And same deal for using your colors when you're graphing. That's why I had you mark them here. If you're not plotting your points in color, then again it gets really confusing as to which dots go with which data set. And last one at 35.6. So right about here. Again with a ruler. Notice I'm using a ruler to draw all of my lines, because we never, ever, ever draw a straight line on a graph without a ruler. And the third one, I'm going to do that as quickly as I can. 12.3, 16.4, 20.7, 24.9, 29.1, there, 33.2. See, when we get higher, even teachers have to use 2 hands. 37.5 for this one, a little below there. And the last one at 41.6. So right about there. Now when you're graphing your numbers, you may find that your lines are kind of right on top of each other. And that's okay. All that means is that your dune buggies were traveling at about the same rate. Mine look a little bit different because I used some different materials. So now I'll just graph my last one. And get that done as quickly as I can. 0.8, 10.7, 12.4, 14.1, 15.8, and 17.6. So one more time, when you are graphing, you should be graphing your data sets, not mine. They should be different from mine. So now we have our 4 lines drawn on our graph. Now I want to make a little note underneath. So I'm going to flip this open and I'm going to write some notes underneath. So do this on your paper. Write this down underneath the graph. This is a distance time graph. Now it can also be a position time graph, because you could say that this is the position of the dune buggy at each time mark along the way. It's a total distance graph. How far had the dune buggy gone at each point? Okay, they all kind of mean the same thing. How far was it? So this is a distance time graph. The slope of a line on this graph represents velocity. And in parentheses we're going to put displacement, just to remind ourselves, over time. So this is a distance time graph. The slope of a line on this graph represents velocity, or displacement over time. So if I were to find the slope of each one of these lines, that's going to tell me the velocity of the dune buggy, or how fast was the dune buggy going. Well, guess what? We're going to do that. But we're actually going to do it two different ways. So I can find two different average velocities here. I can find out what was the average velocity over the entire trip, or I can think, what if I want to know what the average velocity was for each of these little time intervals? Every time that spark timer ticked, I can find it that way also. Let me show you the first way first. So the slope of our line, the average velocity over the entire trip. I'm going to start with my dark blue because that was the first one that I did. And the way that you do that is find your last dot, and it was at 24.2 centimeters, and I'm going to just write directly on my graph. So 24.2 centimeters is how far it went, divided by how long did it take? 1.0 seconds. And I really hope that you don't have to put this in your calculator. 24.2 divided by 1 gives me a velocity of 24.2 centimeters per second. Okay, you should be writing this in the same color that you did your graphing with, so you know exactly which ones go together. I'm going to go ahead and find those velocities for all four of my lines. So my light blue, my last point is at 35.6 centimeters. And it took 1.0 seconds to get there. 35.6 divided by 1. 35.6 centimeters per second. And the next one is my purple. Okay, my last point is at 41.6 centimeters divided by 1 second gives me 41.6 centimeters per second. And my last line here, my last point was at 17.6 centimeters divided by 1 second. 17.6 centimeters per second. So that's my average velocity over the whole trip. And hopefully what you're noticing is that when the slope of the line is steeper, meaning it's pointing higher on the graph, that's a faster velocity. The fastest one has the steepest slope. As you become more shallow, the speed goes down. Okay, the velocity is slower. The shallower your line is, the slower you're going. So what if you had a zero slope on this graph? How fast would you be going? You wouldn't be moving at all. The next piece we want to figure out is what was our average velocity for each one of these intervals, or we can call it per tick because it was the spark timer ticking on that tape. And I'm going to still write my workout over here, but I'm actually going to write it in the column on the side just because that's where I have space. You write it wherever you have space in your journal. Just again, make sure that you're using the color that you used to make the graph to begin with. So our distance is actually the same. Our total distance, 24.2 centimeters. Only now we're going to divide by how many time intervals did we have. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now instead of dividing by 1 second, we're going to divide by 10 ticks. So again, hopefully you don't need your calculator. 24.2 divided by 10 gives us 2 point, and we're actually going to round it to the tenths place because that's where all of our measurements were taken to, is the tenths place. So we're going to say 24.2 divided by 10 gives us 2.4 centimeters per tick. Now I'll do it with my light blue. Okay, again, same total distance, 35.6 centimeters divided by 10 ticks. 35.6 divided by 10 is 3.56, which rounds up to 3.6 centimeters per tick. And the third one, my total distance, 41.6 centimeters divided by 10 ticks. 4.16 rounds up to 4.2 centimeters per tick. And the last one, 17.6 centimeters divided by 10 ticks gives me 1.76, which rounds up to 1.8 centimeters per tick. Now you have all of your lines drawn. You've got an average velocity for the entire trip calculated for each one of those lines, and you've got your average velocity for each interval or for each tick calculated as well. You should have all of this done on your first graph before moving on to the next video.